In this video, we're going to explore solving quadratic equations by factoring. Now, we've already looked at factoring, and we know how to factor a polynomial expression. Here's the main idea. We want to do the same thing. We want to be able to factor whatever expression we have. We want to know, essentially, where is this going to cross the x-axis? That's the whole point of factoring, is to be able to do that. Well, our goal here is to be able to take those equations, or take those factors that we have, and then actually find out where they equal 0. So we're going to start first by factoring, and then we'll see kind of where we're at with that. Well, first we're going to look at number 1 here. It says x squared minus x minus 2 equals 0. So I know we've looked at kind of shortcut ways to do it. We've looked at the area model. I'm going to go ahead and just use the area model because we've got that familiarity with that, that structure. And I'm going to create my area model expression. And I know in the upper left box I'm going to have x squared, and the lower right I'm going to have negative 2. So again, I want to think about how am I going to get x squared, and that would be x times x. And the negative 2, really I don't have many choices here. It's going to be a negative 2 and a 1, or a negative 1 and a 2. But my goal is to add up to a negative 1x in the middle. So I think I'm going to use a negative 2 and a positive 1. And just to double check, I've got a 1x and a minus 2x. When I add these terms together, I do get negative 1x, so that is the right factor combination. So what I'm going to do is take those two factors, x minus 2 and x plus 1, and I notice my other side was equal to 0. That's what I want in order to be able to actually go ahead and factor, is I want one side of the equation to equal 0. We're going to apply something called the zero product property. And here's the main idea with it. These two things represent numbers, x minus 2, x plus 1. They're factors, but they're actually numbers. So if I find out what x is, I could plug it in and find out what, for instance, 5 minus 2 or 7 plus 1 equal. Well, what I'm noticing here is because I've got these two things multiplied together, they equal 0. What that allows me to conclude then is at least one of these has to equal 0. The only way to multiply two numbers together to get 0 is if at least one of them is 0. So I have my first one here, x minus 2, that could equal 0. I'm going to set up an equation. Or I got my other factor, x plus 1, that could equal 0. So when I solve this, I'm going to treat it as any old linear equation I've been doing for a really long time. I'm going to add 2 to both sides. And over here, I'm going to subtract 1. What we end up having is what's our solution to our quadratic equation. If we were to graph this one, and I'm just going to do a real rough sketch of it, what that means is my graph would cross here at negative 1 and at positive 2. It would look something like this. And those are my two solutions. The solutions to the factor, or the equation that's set up with the factors, are the x-intercepts of the parabola. And number 2 is no different, except for the fact that we have our x term is missing. But it's still the same idea. If I'm using the area model, it just makes it a little bit easier for me, actually. Because I have x squared, which is x, and a negative 4. I want these terms to add up to 0x. So I think I'm going to use a negative 2 and a 2. 2x, negative 2x, and it works. So my factors are x minus 2 and x plus 2 equals 0. Using the zero product property, take each of your factors, set them equal to 0, and solve. So add 2 and subtract 2. If I were to graph it, it would look something like that. So again, negative 2 and 2. Those are my zeros of the quadratic graph. Let's look at one like number 6 where we're missing our c term. That one's gone. Again, we can still use the area model for this. And I know that this is an x squared, so x and x. These have to add up to negative 4, but my last term here is actually a 0. Well, that's good news, because if I know one of them is a 0, or the last term is a 0, I know one of the other factors is 0. So that has to be a 0x. If they're supposed to add up to negative 4x, this has to be a negative 4x. making that a negative 4. So my factors then are x plus 0 and x minus 4. So when I set them equal, x plus 0 equals 0, x minus 4 equals 0. So x is 0, or 4. Graphing it would look something like this. But again, same idea. Once we factored it, we take our factors, we set them equal to 0, and we go from there. Number 9, I'm going to do this one using guess and check, only because I think the area model could get a little potentially messy for this one. So I have 4x squared, I've got 3x, and a negative 7. So if I'm using guess and check, I think I'm going to try a 2x and a 2x first and see what happens. Factors of 7, so I think I'm going to go a 7 and a 1. And let's see, that would give me a 2x and a 14x. I can't make a 3 out of those. I don't really have any other choices for 7. It's only 7 and 1, and if I flip-flopped them, it's not going to work either. So I think we're going to have to go to 4 and 1 for x's, 4x and 1x. And let's go a 7 here and a 1 here. So this would give me a 7 and a 4. And I want to make a positive 3, means this one has to be negative. So that should be a negative 1 and a positive 7. So that's my factor combination. Again, same idea as the area model. I want the right factors, because once I have those factors, I'm going to take them, set them equal to 0, and solve. First one, the one down here is going to be the easier one to do. Let's solve that one first. So if I solve that, I'm going to add 1. So x is 1. And for this one, I'm going to subtract 7 and divide by 4. So x is negative 7/4. And again, graphing it would look something like this. So I call that 1. Negative 7/4, roughly negative 2, a little bit further to the right, negative 1.75 actually. But that's kind of the idea, that once we are factoring, we've already done that before, we're going to take each factor, apply the zero product property, which means take that factor, set it equal to 0, and then solve it. And once you've got them, you have your two solutions, which are also called roots.